101. Today we're going to be talking about solving quadratics with what is called the quadratic formula and also square roots. We've already been through these topics before, so you guys are already experts on it, but I just want to make sure that we review this because this is one of those fringe things that may come up later in other math classes. So let's go ahead and jump into it. So, whenever we solve quadratic functions, we are looking for the x-intercepts of the functions. X-intercepts are also called zeros, roots, and solutions. Those all look like they're very difficult to read, so let me make it just a little bit bigger. All right, that's a little better. So, one method to solve this is by using factoring. Now, I'm not going to fill in the rest of this because I want to make sure that we're focusing on what's important. So before I jump into this, I'm going to rewind just a little bit and I'm going to talk a little bit about what exactly we're doing. So whenever somebody's asking you to find a solution to a quadratic equation, anything with an x squared as its highest exponent, they're essentially asking you to find your x-intercepts. That's what we want. We want our x-intercepts. Now, there's a lot of different ways that we can do this. Of course, we can use our calculator. Of course, we practice it a million times, factoring. We can also use those square roots, or radicals is the broader term. And we can also use that quadratic formula. Now, all of these different ways give us exactly the same answer. They all go right back to it. X-intercepts. So, essentially, anytime we're solving this, we are looking for an x-intercept. Now, the thing about that is, that means that I can verify my work with any one of these. But how do I know when to use which one? So, I will tell you, for factoring, these are typically with easier numbers. These are going to be with all whole numbers. You're going to be able to find the factors really simple and easy. Square roots or radicals, you're going to use that whenever you see, for example, x minus 3 all to the power of 2 is equal to 192. So when you see things like that, that's when you'll use a radical. Now, as far as the calculator and the quadratic formula, those are kind of the same thing. This quadratic formula is something that assists you with finding the exact answer for those that don't lie on whole numbers or easy decimals. So these might be something like the square root of 3, which is 1.4, blah, 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 blah. Now, so the thing about that is that we only use this quadratic formula if we want a super exact answer. I'm talking no decimal places. So these are going to have some of those radicals like the square root of 20, square root of 17, those weird ones that are just really long. And we're going to leave it in radical form to keep our answer exact. As opposed to putting it through the calculator, it's just going to spit out the decimal version. Okay? So all of these are exactly the same. They do exactly the same. Don't let anybody trick you and tell you that they don't, because they do. All right? So, for example, here, I see these. I'm trying to figure out how in the world to solve this. Now, of course, I could go ahead and factor it, but I'm going to go ahead and on this particular page, I'm only going to do my quadratic formula. Now, anytime I want to use this quadratic formula, always has got to be written in what we call standard form for a quadratic. It's got to be equal to 0 or a y or a f of x, okay? Everything's got to be on one side, always. The reason is, this means that y is equal to 0, where my x-intercepts are, okay? And I just use this formula over and over. So negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. And I can go ahead and start simplifying. I'm going to go through and I'm going to change all these double negatives into positives just to make it easier. Squaring something is going to make it positive. So let me go ahead and rewrite what I've gotten so far. Let me go ahead and keep simplifying. And at the last step, I can go ahead and break it apart. And I end up with two separate values. Now, one of them I use the plus, one of them I use the minus. Totally fine. That is exactly where this is going to touch. If I wanted to verify this in my calculator, I could go ahead and run a polyroot, which would give me those two numbers. So I'll go ahead and go over here. I'll say find the roots of a polynomial, and I'll go ahead and type in those values. 1, -6, -16. And it's going to spit out the equation for me, and look at that. Same exact numbers. I could also go ahead and graph this, and I'll call this FEX1. And I'll put in my original equation, x to the power of 2 minus 6x minus 16. And look at that. I ended up with somewhere around 8, somewhere around -2, but I just want to verify. So let me go ahead and do a graph trace on this. And it sent me way down there to that y-intercept. That's not what I'm looking for. I'm looking for a 0, and it is indeed located at -2. Let's keep going. Way up here. And again, my 0 located at +8, so I got exactly the same answer. I did this one correctly. So let's go ahead and move on to example number 2. So here, they did not offer me an equation that was set equal to 0. Instead, they offered me something that was equal to 6. I cannot solve this. I can't use factoring. I can't use the quadratic. I can't do any of those cool things unless I rearrange this. So I'm going to be the lazy person, and I'm going to go ahead and I'm going to rearrange this by just one step, just because I want to make it simple. And I'm going to go ahead, and just so we can really drive home the point, I am going to just write out all of my values over here on the side. So let's go ahead and plug those in. -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Now I can go through and look for double negatives. I see 2 of them here. I'm going to go ahead and change them because they're multiplying. And now I'm going to go ahead and continue to simplify. So -5 plus or minus, all divided by 12, square root of 25 plus 144. Okay, let's keep on going. -5 plus or minus the square root of 169, all divided by 12. Okay, square root of 169. Oh, that's 13. All right. So I'll go ahead and simplify it just a little bit more. Okay, so we're getting a lot closer here. So let's go ahead and continue. I'm going to go ahead and break this one apart. So negative 5 plus 13 over 12, negative 5 minus 13 over 12. And I end up with my two answers. Now, of course, these were kind of the easier problems. These had numbers we could have probably factored. This one would have been 3x minus 2 multiplied by 2x plus 3. Ooh, magic, huh? But what about those more crazy ones, like this guy? So let's go ahead and identify each one of these. 2, negative 3, negative 5. Negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. All right, so I see a couple double negatives. I'm going to keep on simplifying. And I end up with my two answers. Now, sometimes you can end up with still having radicals. These might not be a perfect square. These example problems are the super easy ones, okay? So, another one. I'm going to go ahead and I'm going to move both of these items over to the other side. Now I can go ahead and go through my process. So A, B, C, 9, negative 7, negative 4. So negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. I see a whole bunch of double negatives again. They love giving us those kind. I'm going to go ahead and fix that. And let's go ahead and start simplifying. All right, so let's keep on. Let's see here. This will be 3. 193. Now, if I take the square root of 193, that gives me a really ugly decimal. It's like 13.89, blah, 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 blah. Okay? So my two answers are going to be 7 plus the square root of 193, all divided by 18, or 7 minus square root of 193, all divided by 18. So I have those two solutions. Now, this is as exact as it can get. We don't have to worry about our decimal not being accurate. This is as exact as it gets. However, let's see what that looks like on the calculator instead. So I'm going to go ahead and I'm going to go over here and I'm going to run a polyroot. So 9. Oh, no. Okay, 9, negative 7, negative 4. Okay. And look at that. They gave me these really ugly decimals. And I would venture to suspect if we plugged these in, we would get even uglier decimals if we plugged in the full thing. So as you can see, quadratic equation is going to tell me the exact answer. This is for those ones that are kind of weird, kind of too difficult to factor, and are not so straightforward. So I want you guys to go ahead and work on the example question. But before that, I do want to go through some of these square root ones. So I have 4 example problems here. Now, of course, this can totally be done by factoring. Of course, 100%. Except, I just want to make sure that you understand this because this might come up in another math class. So, for this particular one, I see it's x squared minus 144. So I want to get it to where I can take a square root of both sides. Now I can take my square root and it cancels, and the square root of 144 is positive or negative 12. Now I have my 2 answers. Simple. Super easy. Let's take a look at another one. So here's another weird one. Let me move that 5 over. Okay. Well, let me go ahead and multiply by 5 over 1, the reciprocal. All right, so now we're somewhere. X squared equals 25. That means x is equal to 5. But let's do it anyways. Oh, I totally forgot. Plus or minus 5, because there's 2 answers to those. Let's look at the next one. Here they gave us kind of a weird one. Okay, let me go ahead and divide by 4 to get rid of that. Because remember, we're trying to get to a point to where we can take a square root. So that would be, let's see, 75 plus 6, 81, I think. Let me just check that with my calculator. I want to make sure. Yeah, 81. Okay. So now that I have this, I can go ahead and take the square root of both sides. They cancel over here. And I end up with this. But my x is not isolated yet. I've still got to get rid of that 5. So let me add 5 to both sides. Okay. Now I can split it apart. 14, negative 4. There's my answers. Super simple. Now, of course, this doesn't work out with every problem. There's only specific problems that this is useful for. Okay? And these can totally still be factored if you went ahead and multiplied out the binomial up here and then moved this to this side and did all that good stuff. You could still totally factor it. But this is probably the simplest route for this one. All right, next one. A cliff diver dives off a cliff 70 feet above water. So let me go ahead and draw this. 70 feet. Here's my little person. Maybe they have long flowing hair. Okay, and it can be modeled by that function. How long is the diver in the air? So they want to know how long does it take before they reach my ocean down here. Well, the ocean is going to be located at 0 feet because that's how they were measuring this cliff. So h is equal to 0. 0 equals negative 16t squared plus 70. So let's go ahead and try and solve this using that same method. Oh, this one looks a little scary. It's got a negative over here. But if I divide by this coefficient, I end up getting rid of that negative. Now I can go ahead and take that square root, and I'm going to end up with 2 possible answers. Now, they asked me how long, which tells me this t value is in seconds. So it's either positive 2.09 seconds or negative 2.09 seconds. I've never heard of anybody going back in time in real life. So it's got to be positive 2.09 seconds. All right, go ahead and get started on your second example question, and I will see you guys next time.